All right, lesson 4.6. So last class when we were doing lesson 4.5, we talked a lot about asymptotes, vertical asymptotes in lesson 4.5. Today, we're going to be dealing with inverse trigonometric functions, also known like as arc sine, arc cosine, arc tangent, which I'll show you in just a moment. I'm going to open this up because there's something I'm going to pull out first before I get started. Is I'm going to go open up the calculator from our pre-programmed list. That is, if it opens, number 14. I use calculator 14 today for, well, at least on the bell ringer. That's from last class. So right there, graphing trig functions. I'm going to open that one up. And not only that, I'm going to go back to this 4.6 instructions. The unit circle help. I'm going to be using this unit circle right here, which comes from this document, unit circle help. If you click that, that's where I copied that photo from. It's right there. If you want it to follow along at home, or if you want to know where to get one, that's where you go. But I'm going to leave open the trig graph first. So number one asks us to find the vertical asymptote and sketch the graph of y equals 2 secant x. So I'm going to clear this just to make it easier to see first and foremost. So we want to know, where are the vertical asymptotes for 2 secant x? So as you can see this graph, I'm actually, as it turns out, my first asymptote I've thrown in there is in the right location. But an asymptote, by way of reminder, this actual graph, 2 secant x is shown in blue, has gaps in it. There are areas where this graph does not exist at all. Domain values where the graph doesn't exist at all. I know there looks like there's a huge gap here, but as far as the domain goes, there's not a huge gap because the domain is used down here below. But these two parabolas, and that's what they are if you zoom out, they look like a bunch of parabolas, do have a break in between them. It's not all reals. There's breaks in the x-axis, and that's one of them at pi over 2, which we're about to learn. That's what that is, pi over 2. And so the question I'm going to lead off with today here is if you're trying to find a vertical asymptote, how do you actually solve for that mathematically? What is it we do to solve for a vertical asymptote? So different things I've seen and heard is that we need to find the ratio. We need to use the unit circle. And I agree with all those, but just to directly answer the question, mathematically, how do we solve for a vertical asymptote? These occur, or they don't truthfully occur. We plot them whenever we're dividing by 0. That's what breaks up the graph. So the 3 steps I gave you last class is, 1, to determine the ratio so that we could find out what is doing the dividing and the function secant. That's the first thing we need to determine. What is doing the dividing on secant? And so over on this graph, I'm going to slide all the way down to the bottom so you can see the 6 trigonometric functions. And I went too far when I covered that up. Let me go there. There we go. And so now when I see secant, I can discover, oh, secant is the same thing as the hypotenuse divided by the x value in terms of right triangle trigonometry. Okay, so if a vertical asymptote is created whenever we divide by 0, then what I need to do here is solve for when x equals 0. And as stated by a student earlier, what's the best way of solving for when x equals 0? The unit circle. We're going to use the unit circle and we're going to determine when does x actually equal 0. So what angle does x equal 0 at? And so using this unit circle here, I would go around until I found an x value of 0. So remember, these are the x's. It's every point, every coordinate point is x comma y. So I'm just looking for 0. And specifically the very first one, there's the very first 0 that's an x. And so the angle that it occurs at, in terms of radians, not degrees, is pi over 2. And so that's where this occurs at. So what does that mean? Well, we just determined that if there are no horizontal asymptotes, excuse me, let me say it again. If there's no horizontal discontinuities, Nope. Try one more time, Mr. Voorhees. If there's no horizontal transformations, there we go. Let me write and then I'll talk. If there are no horizontal transformations, that's where the first asymptote is going to occur. Now, there may be some horizontal transformations. Let's check. So here's what our third step was. We write out the pi over 2. And with trigonometry, without transformations, each asymptote occurs in pi away from one another. So we started here. We started with the initial angle, and then we add in pi to find all the others. And on this particular problem, when I look up, I have no horizontal transformations, none. Now, this right here is a vertical. It's on the outside. It's multiplying times the secant there. You can see that's a vertical transformation. And I know you would think, oh, well, if it's a vertical stretch, surely that affects my vertical asymptote. The answer is no, because even if you stretch this dotted line upward, it already goes upward forever. So stretching it doesn't change anything. Only horizontal transformations make a difference. So since there are none, all you have to do is say that n is an integer, and we are done. This formula right there would solve for all the infinite number of asymptotes. And so when you check what I had over here, you'll see, let me zoom in a little bit. You'll see that that does pi over 2 creates the first asymptote, and that they are in pi away from each other. I can test this by moving around n. And so if I make n 1, you get the first asymptote to the right. If I plugged in and made a -1 for n, you get the first asymptote to the left. -2 would provide the second asymptote to the left, and so on and so forth. It's same for the positives. So all that's happening mathematically when you plug in an n value that's an integer is it just determines what the next or some number of asymptotes away from the original. So whatever n is, if n is 5, it's 5 asymptotes away to the right. So it's 1 asymptote, 2, 3, 4, that would be 5. So that was what we went over in lesson 4.5. Now, in previous lessons, we specifically lesson 4.3, we did unit circles. So let me copy this in here. And I gave you values, and I said, hey, what is that value if it exists? And I trained you how to use a unit circle. And so we would look for tangent of -2 pi. So if you look over here on this, let me just copy this here to also copy. Okay, if you look on this, you're looking for -2 pi. And you can see on the angles, it's not there. And so you might remember this. We can use a coterminal angle. And so here's what coterminal. Coterminal means terminal, the angle ends in the same place, co, together. So they end together in the same spot. The formula for this was whatever your angle is plus or minus 1 revolution. Right, a revolution means a full circle. So in this one, I'm in radians, so I'm looking at radians. -2 pi is not on there because it's too small. So what I would do is I would take my -2 pi and I would add the revolution. And so 1 full revolution is a 2 pi. -2 pi plus 2 pi is 0, which means tangent of -2 pi is going to equal the tangent of 0. And we'll discover what that is once I remind you that tangent is y over x. Sine is y, cosine's x, tangent is y over x. So if I go to the angle 0, here it is. I'm looking, that's theta equals 0. And that's my y. That's my x. So tangent is y over x. So the value is going to be 0 divided by 1, which simply put is 0. That's our answer in this problem. All right, let's take a look now at number 3. Which angle has a negative sine value and a negative cotangent value? Now this honestly also was lesson 4.3. And so what I want to remind you here, actually, instead of using this.
Hey, Mr. Voorhees, I'm going to my ortho appointment right now.
Okay, so previously I copied that unit circle and there was a reason for that because I knew I was going to use it. So now let me use this unit circle. Okay, so on this one it says what angle has a negative sine and a negative cotangent? And basically they give us these angles, and none of these happen to be on the unit circle. Now, if you're doing some logical thinking, you could realize that pi divided by 7 is going to be in between pi divided by 2 and 0. You can just kind of see this is pi divided by 3, pi divided by 4, pi divided by 6 is there, pi divided by 5 would be somewhere in the middle, pi divided by 7 is going to be somewhere over in here. That would be pi over 7, which I'm going to say that A here is going to be a first quadrant angle, quadrant 1. That's where A would be. 5 pi over 7, that's more than 1/2. So think about anything divided by 7. Half of 7 is 3.5. Since 5 is bigger than 3.5, this is past half a pi, but yet 5 is not as big as 7, so it's less than 1 whole pi. So it's somewhere located in here. Now, if I were going to do my best dividing, I'm getting like 0.7 and some change. So it's going to be bigger than 2/3, which is 0.66, but smaller than 0.75, I think. So I'm going to guess that it's somewhere over there. I'm going to say that's where angle B would point. The terminal end of angle B would be right there in quadrant 2. I'm going somewhere with this here. Okay, just follow along, please. Here's 9 pi over 5. Excuse me, 9 pi over 7. Can't calculate. That's a little bit more than 1. But yet it's not, remember half of 7 is 3.5. It's not 1.5. It's not 10.5. It's less than that. So this would be somewhere over here. 7 going into 9. It almost goes in 13 times. It's almost 1.3, not quite 1.3. I'm going to guess it's somewhere over here. I could be off, but I'm just going to locate it there for the time being in quadrant 3. And I bet by now you've guessed where quadrant answer choice D goes. Let's see, 13 divided by 7. That's almost 2 pi. It's bigger than 11 divided by 6. 13 divided by 7 is somewhere over here. That would be answer choice D, located in quadrant 4. Okay, so now that I've written all that out, how could we solve for this? We know we have to have a negative sign. So sine is y over h. So if I have a negative sign, that means it's less than 0. And if it's sine, then that means the y divided by h is less than 0. And if I'm really interested in my y value, because on this is my y-axis, this is my x-axis, I could multiply by my h. And because of the math rule that h is always positive, my inequality will stay the same direction. Remember with inequalities, this is like an algebra 1 rule. If you multiply by a negative, you need to flip the sign or flip your direction of your inequality. If you multiply by a positive, it stays the same. H is always positive by rule, so the inequality stays the same direction. That means y is going to be less than 0. I just found out I can eliminate all of these. Any answer that's above the x-axis is going to be wrong because y has to be negative, which for our problem means A and B are out. Now the problem also said they have a negative cotangent. So cotangent is x over y. If you're checking over here, cotangent is x over y. So cotangent is less than 0. It's negative. Well, cotangent is x over y. That's negative. Now we know that y is negative itself. So real quickly, I'm going to just put in a little negative there. And so when I solve for my x here, I have to multiply by this negative number. I'm putting negative y, but I don't actually mean the opposite of y. I mean that y is negative, what we've learned. So those go away. But rule of mathematics, if you multiply by a negative, the inequality has to switch directions. 0 times anything is still 0. So this means x is positive. What I just now determined is that C is out also because x has to be positive. So the answer on this problem is D. So that's a review of previous lessons. Oh, and I didn't walk you through this. Let me just clear this calculator. What you could do also, this is a great little trick, is using technology. You could type in all of the answer choices. I'm just going to jump straight to the answer as sine and cosine. So let's just say sine, and make this easy. And here, sine and, oh, cotangent. Sorry, it was sine and cotangent. Now just put A, and you could type in all your answers to check out, but we'll say it's 13 pi divided by 7. And you can see that both of these are negative, like they were supposed to be. I could switch that around. I just used A to make it faster so I didn't have to do this more than once. You could try a different one, like I'll try C, for example. 9 pi over 7. Notice that sine was negative, but here cosine would be, or cotangent would be positive, so that would not work. Okay, so there you go. That's just kind of a cheating way of using technology to come up with a solution as well. All right, let's start with some new stuff here. Well, when I say new stuff, technically it's not that new. We did see this on lesson 4.1, the very first day of chapter 4. Arc sine and arc cosine, which is simply put the inverses of sine and cosine. So old school name is arc sine, but it's represented by this symbol, sine inverse. And so a lot of times you might just see it, let me write it this way, as y over h equals theta. Now, why is that the case? Well, because the normal sine, or the sine function, is y divided by h. And so if we're dealing with inverses, normally we'd say switch the x and y. But with trigonometry, it's a little bit different. We're going to swap the angles with, thinking of a triangle here, with the side length. So the angle and the side length swap places. And so sine inverse would be y over, sine inverse of y over h would equal your angle. So that's basically what's going to happen. Cosine would be nearly the same except for, excuse me, arc cosine. There we go. Arc cosine would be x over h. And then arc tangent. Now, someone might be asking the question to themselves, why is it that you don't have all 6 trig functions here? Well, technically you do. If you go to the calculator, you'll see that they're listed, all 6 of them, inverses. But why did the notes not include them? They don't include them because you use the arc functions or the inverse functions whenever you're missing the angle. You have the side lengths. Well, if you have the side lengths, you don't ever need to have the reciprocals because you already have both side lengths. You don't need to know which one's on top, which one's on bottom. Remember, we use these functions. Let me come back over here. We use these functions whenever you had your x or y and did not have h, or in this case, you did not have your x. We use the reciprocals to help us put the unknown in the numerator. Well, over here, we're saying we know both ends of the fraction. So it doesn't matter which one you pick. For that reason, the notes only list off sine, cosine, and tangent. It's just you don't have to use the other 3. With that, let's get started. So inverse with trigonometry means flip these 2 around. Now, as I go through, I'm going to cover up some stuff because ultimately I don't like the pictures from the textbook. And so this first one says find sine inverse of square root of 2 over 2. And so basically, here's what we're doing. We're using the unit circle, and I can show you, we can use the calculator too today, but I'll just show you this. If I wanted to find sine inverse, I need to remember that sine is y. Sine is y. And so basically this is saying my y is square root of 2, my h is 2. And if I look on the y-axis, I'm looking for the y value that has a height of square root of 2 over 2. Or you could say this way, check out all your heights, and you're looking for the first y that has a value of the square root of 2 over 2. That's a negative square root of 2 over 2. That's not good. But you can go around, you're looking for the very first occurring. So you're going to see out of all of these going around, there's only 2 that work. At max, there's only going to be 2 that ever work for you. In this particular case, where y is a square root of 2 over 2 is this height right there. You have this is a usable value, and this is a usable value. All the others are wrong. None of those y's match up. And I did not realize I was 1 short. There we go. So none of the other y's match up. Notice that's a negative, so it doesn't work. Okay, let me continue making the x's. Now, your solution in mathematics, we're going to learn in a little bit when I show you the graph. I think it's example 4, that for inverse, the graphs are not defined beyond a certain point. This value will not be the correct answer because it won't be defined that far around. I'll get to that in a moment. Like, what are you talking about, Mr. Voorhees? I will show you. Or the range will not reach 3 pi over 4. The easiest way to say this answer is going to be 1 pi over 4. So out of the two options, you have theta equals pi over 4, because that's where that occurs. Sine pi over 4 gives me the square root of 2 over 2. I also have this value over here that says the sine of 3 pi over 4. Whoops, I should have wrote that right there. Let me see if I can switch it. Nope, I can't. I'll just have to erase it. That the sine of 3 pi over 4 also equals the correct value. However, what we're going to select is the quickest occurring. What I mean by that is the shortest path. So you're going to look at the theta that happens the fastest. So I will call this theta slow, because it takes longer. It takes a longer path. So I'm not going to choose 3 pi over 4. I'm not going to say that's the right answer. What I'm going to take is pi over 4. That one's the fastest one. So the sine inverse of square root of 2 over 2 is going to equal pi over 4. Now, I know I said a lot there. I'm trying to explain you through why one answer is correct while the other one is incorrect. So we're going to take the first that occurs. And so if I come over here and I'll show you sine, you can do the power and type in -1, or you could have just gone to functions like I showed you earlier and click sine inverse. And I'm going to put this in parentheses here, square root 2 divided by 2. You get this value, which happens to be pi divided by 4. Notice it's not 3 pi divided by 4. That other option we saw, the decimals do not match. So for that reason, pi over 4 is the correct solution. Again, showing you from here, you're just going to take the quickest that occurs. That means you're typically going to look for your answer in the first quadrant or the fourth quadrant. The only difference is if it's cosine, it'll be first or second, and the same with secant. But typically, you're going to be looking in these two quadrants for your answer. All right, so let me give you another one. Again, I'm going to cover up what the textbook gave us as the solution here. All right, so using this, I'm now looking for, again, it's arc sine, which means inverse sine. This is my y, so my y is negative. I need to be going down, and my h is 2. And so I find this value right there. Let me put it on this side. There's my value. I also have 1 right there. And so some students will say, well, the quickest path is going around to 4 pi over 3. It's definitely quicker than going around to 5 pi over 3. However, there's a quicker path. It's to go negative. That's the quickest path. If this one going around was 4 pi over 3, 4 pi over 3, I should have used different color. If that one was 4 pi over 3, this one's 5 pi over 3 in length. This one is only negative theta equals -1 pi over 3 in length. It happens really fast. It's the quickest. And how do I know it's that? It's because it's at the spot. It's coterminal with 5 pi over 3, but it's one full circle going around this way. The first portion cancels out that portion, and so it just leaves us with that left. Okay, so mathematically, what does that mean for us? It's 2 pi minus 5 pi over 3. 2 pi minus 5 pi over 3 is negative pi over 3. Did I say that backwards? I did. 5 pi over 3 minus 2 pi. Sorry. 5 pi over 3 minus the 2 pi gives us negative pi over 3. That's why it's that one. You could, with radians, it's always going to be the common denominator. Since it's just straight down, it's negative pi over 3. Negative pi over 3 would be our solution here. So let me rewrite this. Sine inverse negative square root of 3 over 2 is going to equal negative pi over 3. Now, if you're totally lost right now, it doesn't surprise me. But we have a whole bunch of examples to kind of make sense out of this. Let's type this in and check it. And you will start to see your calculator can be your best friend here, because if you don't know what the correct answer is, you can always just check and see, plug and chug, or guess and check, whatever you want to rhyme you want to use, and you can come up with your solution. We said the possible options were 4 pi over 3 and 5 pi over 3. You can see those decimals do not match up, but these two do. So the answer would be negative pi over 3. All right, let me do one more for you. Let's try sine, and this time I'm going to use the calculator first. And I'm going to type in sine inverse of negative 2 pi. And you'll see it's undefined. That's what? Undefined? Shouldn't I have an answer here? Well, let's see why it's undefined. Remember, we're saying that this is my y, because it's inverse, and my h must be 1. Well, this makes no sense. We're saying the y-axis is negative 2 pi. That means it goes down about 6.28, but the hypotenuse is only 1. So we have a triangle here, if I kind of draft it, where the y-axis goes down, where y would be like negative 6.28, roughly 2 pi. But that the hypotenuse, we don't know what x is, so I'll just do random little x. But the hypotenuse only has a length of 1. Explain that one to me. How could we have a length of 1 and get a full triangle? We can't. The h has got to be bigger than the y. H has got to be the longest side. For this reason, it's undefined. Okay, now if you're going, that still makes no sense. Well, let me show you the graph. Maybe the graph will help you. Let me clear these. Here's the graph. Y equals sine inverse. And I'm going to put in, oops, wrong one, power. That's going to look more power. There we go. Sine inverse of x. So here's the graph. And let me make this a little bigger here and get my settings right. What you're about to learn is that the domain is going to go from negative 1 to 1. Actually, to make it easier to see, let me go to negative 2 and 2. And y is going to go from negative, I'll just make it negative pi to positive pi. And let me count this by pi divided by 12. And I'm realizing that that is really close. Let's not do that. Let's just do pi divided by 2. Okay, so here's the actual graph. And I want you to notice the domain, that means the inside value, is only allowed to be between negative 1 and 1. That's because it's the y divided by h. And h is always greater than y or equal to. If it's on the axis, it could be equal to. So this one does not exist because the y-axis is greater than the h. The values have to be in between. H has to be greater, so this will always, since it's a smaller number divided by a bigger number, it'll be less than 1 when you take the absolute value of it anyways. So this was outside the domain. Negative 2 pi would be over here, like negative 6.28. That is outside the domain. So that's why it was undefined. The graph did not exist there. All right, so I have one for you to try. You can use a plethora of methods here. You could use my unit circle, or you could use the calculator to try to come up with your answer. Example 2. Now let's do the same thing, but we're going to take a look at cosine. So we're taking a look at cosine now. If my calculator will paste the unit circle, maybe, maybe not. Let me just grab a new one. How about that? Guess I lost it. All right, if I'm looking for cosine inverse of 1, what that's saying is the x over h, because remember cosine is x divided by h, is equal to 1. So that's my x, and here I would just put it over that, like that, is my h, is 1. So I'm looking for an x value of 1, and as lo and behold, there it is. It's the first one, because again, these are endpoints x comma y, or cosine comma sine. That's how the unit circle works all the way across. So that's my value right there. So your angle that it comes from, because that's what it's going to be equal to, is this angle right over here. And it's the first angle that occurs. 0 happens faster, 2 pi goes all the way around. So that's 2 pi. This is 0. 0 is quicker, so the answer is 0. Cosine inverse of 1 should equal 0. Let's check with our calculator. Cosine inverse of 1 does equal 0. Okay, let's try 2b, example 2b. Again, I'm going to cover this up. All right, if we wanted to try to solve for arc cosine, well, arc cosine simply means the cosine inverse of negative square root of 3 over 2. Now I can type this in the calculator first and get the decimal value, but that doesn't do us that much good. So let's solve for it over here. And reminder that this is my x and this is my h. So I'm looking for a negative x value. H is always positive by rule, so it's a negative x. So when I go to my x-axis, I'm looking on the left side, and I see that both of these two answers are valid. So you start thinking about which path is quicker. Is this path quicker? We'll call that path 1. There's path 2. Or would it be path 3? Path 3 would be going downward like this. Well, you notice that path 3 and path 1 are actually tied. They're the same distance away from the starting point, but since path 3 is negative, they'll eliminate it for that reason, because if they're the same, they'll take the positive. And so the correct answer is going to be 5 pi over 6. That's what we're getting here, is 5 pi divided by 6. And in a second, I'll show you graphically why it's not 7 pi over 6 or negative 5 pi over 6. So when I come over here and check it, 5 pi divided by 6. Notice some of my decimals match. By the way, if you're trying these in your calculator and you're not getting any of the correct answers that I am, it's probably because you're in the wrong mode. If you're in degrees, you could be getting something totally different. So the correct answer would be 5 pi over 6. And now on this one, let me show you why graphically this was why negative 5 pi over 6 is not the correct answer. If I graph this, cosine inverse, negative 1 of x. Here's the graph. The reason the answer would not be a negative angle for cosine is because if you, the answer we're talking about, not the input. We had a good input. It was not undefined up there. This was a real value. But the reason my answer choice is because if you look at the range, cosines will never have a negative angle. It stops at 0. So you won't ever with cosine take a negative. So the quickest path for cosine will never include a negative, ever. That's why the graph is only on the positive side. Now, do you have to memorize? No. You can do quickest path to come up with your solution, but it won't ever be a negative angle for cosine or secant for that matter. But the other 4 will have negative angles. All right. Cosine, -2. We get undefined. Why is it undefined? Well, this is outside the domain. That's a domain value, and inside x value, notice it's -2. This graph does not exist over there. So cosine -2, cosine inverse of -2 is undefined. Since -2 is outside domain. And just in case you didn't realize what the domain was, the domain, I usually do a capital D, was from -1 to 1. Or if you wanted to use the other symbols, you could say -1 is less than or equal to x, which is less than or equal to 1. That was the domain here, the x values. So this one did not exist because the input, the domain, was outside of its restricted values. Whereas this one, we didn't take the negative angle because that would be outside the range, but it did have a defined domain. That's a good domain. We have that value. So that's kind of the difference there. All right, your DOL number 2. Here's a unit circle to help you out. You can use graphing or whatever else. All right, tangent. Now, I'm not going to lie. Tangent's the trickiest because you have to do a little bit more math work on tangent. Why is this the case? Well, before I start solving this problem, let me remind you that tangent is y divided by x. Sine is y, cosine's x. Tangent is y over x. And the unit circle, unfortunately, does not give us the tangent values. It gives us the cosine, comma, the sine. So to get the tangent, you have to take the sine value or the y value and divide it by the x. Well, here's the problem. Most of the times when we reduce the tangents for most values, you will not end up with a value that appears on the unit circle. So some students might be like, well, wait a minute. I know tangent is y over x. So the inverse of tangent, that's my y value. So there it is right there. There's the y value of square root of 3. Well, there's one problem. This right now currently says that x equals 3. And this over here says that x equals 1. So this, in fact, would not be the point because the values don't add up. So you'll look on there. You'll not see a square root of 3 divided by a 3 anywhere on there because tangent, you have to do some other tricks. So let me talk about the number square root of 3 over 3. Here's the way I think this is easiest to solve. The easiest way for me anyways, I think, to solve this is to say this. Let's get rid of the square root. How do I do that? Well, I multiply it by itself. Square root times itself makes the square root go away. So that's multiplying by 1, by the way. I have square root of 3 divided by square root of 3, which is 1. So I'm not changing this problem. I'm multiplying by 1. That doesn't do anything. But if I don't cancel out, if I multiply across first, you'll see something cool happen. The square root of 3 times the square root of 3 is the square root of 9. And down below, I can't put those together, so I'll leave them separate. Well, here's what I know about the square root of 9. It's 10. What? It's not 10. What is the square root of 9?
3.
3, there you go. I'm trying to see if you're even following along. That's 3. So I now have 3 over 3 square roots of 3. I can cancel the 3's. Since there's nothing left over on top, I put a 1. It's 1 over square root of 3. Now I can find my value. My y is 1. My x is square root of 3. These are positive, so you want the quickest positive occurring. Here's my positive y. There's my positive x. That's my angle here. Tangent inverse of square root of 3 over 3 is equal to tangent inverse. Here's the non-rationalized denominator form, 1 over square root of 3, which happens to be the pi over 6. That's my solution. Okay, could we have done this from the calculator? Yes. Tangent square root of 3 divided by 3. Whoops, not 6, 3. There we go. And pi divided by 6. Notice they match up perfectly. So I did do it right. So what did I do there? I just multiplied by the denominator. That's one trick you could do with tangent. There's a plethora of tricks you can do, but that's just one of them, is multiplied by the square root to get that to disappear. Now let me show you another type of trick we might do. So again, I'm going to copy this. All right, what if we were looking for tangent inverse of 1? Well, 1 is the same thing as 1 divided by 1. So we say, all right, great. I just need to find where y is 1 and x is 1 also. And as soon as we say great, we run into a problem. Because this is a unit circle, which means the radius here all the way around is 1 in length. So you cannot have a x value and a y value being 1 at the same time. Like there's a y value of 1, but the x is 0. Or here's an x value of 1, but the y is 0. You can't have, even if you go out angled, 1 and 1. So all the way around, you won't have, so there's a y of 1, but x is square root 3. Here's a x of 1, but y is square root 3. It doesn't work. So how can we get this value? Well, if you were thinking about it this way, this being 1 up, this being 1 to the right, maybe in the middle, well, the middle happens to be the right values because tangent inverse of 1 divided by 1 is equivalent to the inverse of tangent of square root of 2 divided by square root of 2. Think about it that way. That is 1, and it comes to this point where x and y are equal to one another. And so that's actually going to be your spot. So the answer this points to is pi over 4. And I could write this the way they originally wrote the problem. So inverse tangent of 1 is the same thing as just two equal numbers dividing each other. And that happens for tangent to occur at pi over 4. That's when x and y are equivalent. Now, let's let you try this one here. All right, I'm going to bypass this because we're not in class, but in class I normally do this after showing a hand trick for some of these values, but I'm going to skip that. Okay, so now let's talk about graphing. I showed you some sneak peeks into the graphing, and I want to pay attention to the domain and range on these. This is the inverse of sine. Notice the domain will be values anywhere from -1 to 1, and the range will give you anything from negative pi over 2 to pi, which means this. On a unit circle, for the inverse sine, no, that's not what I want to do. Sorry, I want to move it. The only values you'll ever see are the angles from negative pi over 2 to pi over 2, which means all of this on this side will never be a solution. If you're dealing with sine, you'll never have a solution on the left side. You'll only be dealing with the right side. It'll either be the positive angles or the negative angles. That's the only place you'll ever have a solution. And your domain will range anywhere from -1 to 1. So any of these values, the y values, occurring on this side of the unit circle. Cosine's different than the others. Cosine, and secant for that matter, if you notice, its domain is also -1 to 1. But its range will only give you values from 0 to pi. So cosine is not going to look at these values down here. They're only going to give you answers occurring on the top half of the unit circle. And then finally, tangent. Tangent's going to follow sine's rules. So tangent is going to go from negative pi over 2 to pi over 2. So notice that this is much like sine. It's going to give you values from over here. All right. So graphing. Here's the graph of tangent or inverse of x divided by 2. Now, I don't have much to do on here. You could graph this and see it, but the domain for arctan, I forgot to tell you this, the domain is all reals for the inverse tangent. It does go on forever, but the domain for sine and cosine inverses are not all reals. They're from -1 to 1. So this one would go on forever. Now I have a simple DOL for you. I want you to graph this and come up with your solution, and I will give you a hint because a lot of these graphs are very, very similar. Of just use your coordinate point. So this one is like 2 to the right and pi over 2 up. So go about it that way to solve this DOL number 4, just writing out each of your points as you go. All right, example 5. Now, here I'm going to transition to real world solving, and the difficulty jumps 1,000 times. Not every real world is this difficult, by the way. It's just this particular problem is very, very tricky. So first off, I want to show you what's going on. I'll read it and then kind of walk you through it. It says in a movie theater, a 30-foot, if you remember pre-COVID what those things were, joke, a 32-foot tall screen is located 8 feet above the ground. So here's the ground, and up 8 feet, starting there, you have the screen that stretches 32 more feet. So it's a total of 40 feet on the side. Write a function modeling the viewing angle, theta, of a person in the theater whose eye level when sitting is 6 feet above the ground. So here's their eyes. They look straight across. And we want to know the theta of looking at the screen. Now this picture labels theta 1 and theta 2. What is a little confusing about it is neither of those two angles are actually the viewing angle for the screen. The viewing angle of the screen is this angle that stretches from here to there. That's the theta of the screen. Theta, I'll call it screen like that, theta screen. Now here's what I do know. Theta 2 stretches the whole viewing, and theta 1 is this little portion. So the theta of the screen mathematically will be this one minus this one. If I take away that little portion there, I'm left with my theta, the viewing. So I'm going to just say it's theta 2 minus theta 1. I'm going to write that out real quick. That's going to be, in general, in theory, what's going to be the angle that we're viewing the screen. So now let's do some math here. And to help you see this, I'm going to draw a little triangle, and I'm going to do the best I can because I got to do a couple things with this. Let me get 2 triangles actually, and I'm going to flip this one. Where is it? There we go. Flip, left, right. Okay. So the first thing I want you to notice is from the person's viewpoint, because this will help us get the correct height. What am I doing? That's not how I wanted to do this. I want to get it from. That's not how I want to do it either. That's how I want to do it. There we go. So I want you to look at this big black triangle right now. And notice this is the ground. This triangle is not 40 feet tall. I know it's not 40 feet tall because over here, this is 6 feet off the ground. So I'm going to write it right about there. So this is 6 feet. So a little mental math here. If this is 6 feet tall and this is 8 feet tall, how tall is this area from here to there? Answer, 2 feet. That's 2 feet. And this part is 32 feet. From there to there, we know is 32 feet. Which means the y in its entirety is going to be 32 plus 2. So I'm going to say this y value, I'm going to try in red, is going to be 34 feet. That's the y of this triangle. It tells us the x value is d. So what have I learned so far? This major triangle has an angle of theta 2. And theta 2, if I'm using tangent, because I got x and y here, so if tangent is y over x, then I can say, and since I need to plug in for theta 2, I'm going to say theta 2 will equal the tangent inverse of, and I'm going to put the y, just 34, over the x, which they just labeled d. So there's part 1. I've now solved for theta 2. Theta 2 is whatever tangent inverse of 34 divided by d would be, which we don't know because we don't know the distance. We don't know how far we're sitting from the screen. Next question I need to ask myself is, what is theta 1? So theta 1, if you notice, is that little bitty triangle. So now let me get my second triangle out. I'm going to flip this around. And if I remember how I did this last time, so I think I got the height right. And then whoops, after I got the height right, I then got the width right. Not working. Well, that's going to work the best it can. Okay, now looking at this little blue triangle, we can see that the y is 2 feet. And so I can come up with theta 1. So theta 1, I'm going to use inverse tangent again. And it's y over x. So now my y is 2 feet. And again, I have the same d value. And so I can now say that this would represent my formula for the theta screen, the viewing angle. So there's my answer to part 1 right there. Okay, now I'm going to copy this portion and go to part B now. Part B says, I'm going to paste that right here. It says, determine the distance that corresponds to the maximum viewing angle. So if you want to have the greatest screen value, what distance would you need to be apart? So when I graph this time, I'm going to use the calculator to help me out. I'm going to type this in as y equals, not theta screen. So y equals, and I'm going to say tangent inverse, so power of -1. And instead of 34 divided by d, I'm going to say that's 34 divided by x for Desmos' sake. And we're going to subtract the tangent inverse, oops, wrong key, there we go, power -1 of 2 divided by x. And I'm looking for the maximum y value. So I zoom out and Desmos should tell me, there it is, when you just kind of click around, that it'll give you the maximum point. It's called the critical point. Desmos gives you those. That is the highest point. So the highest angle is 1.095 radians. Let me check here. Yeah, radians. When the distance, the x, is 8.264. So let me just grab this so you can kind of, so I can write on my screen. I'm going to just copy it and paste it over here. So I can write on my screen here. I typed in x as my distance. So x was, the distance was replaced by x. So that means my x-axis is the d-axis. That means that's the distance. And notice my y replaced the theta screen, which means that's the viewing angle in radians. So that's just how to translate. Now, I know this problem was really hard for what we've done so far. You haven't seen anything like that. But that's how you would use graphing. I just want you to know how what I substituted in, and so what values I would be looking for. So the maximum viewing angle, the maximum viewing angle of 1.095 radians occurs when you sit 8.246 feet from the screen. Let me translate this. If you're at the theater and you want to make it the hardest possible to see on your eyes, sit 8.246 feet. That's what makes the screen. Sure, it looks like in some regards it's the biggest, but it's hard to see it because you're so close. That angle is so large for your eyes. It'd be easier if you backed up and the angle was, though the screen was still large, the angle became a little bit smaller in your eyes. That's like the worst seat in the house would be 8.246 feet away from the screen. That's what you determine right there. And this one would be a DOL. Now let's look at composition of trig functions. Now composition is, if you remember, it's that very confusing thing from lesson 1.6. It's where you have one function within another function. It was lesson, I think I just said 1.5, it's 1.6. And what can get really tricky is the domain and range can go crazy on you. Now here it's giving you some rules. This is only applies if it's sine within a sine inverse or cosine within a cos inverse, or tangent within a tangent inverse. I think I said those backwards, but domain and range can go crazy on you. Okay, especially if you start mixing and matching these. Okay, so it's hard to follow the exact rule here. The Desmos we discovered today has a programming error. So maybe if you listen to this years in the future, it won't be, but I will show you that when we get there. So let me show you what's happening. Now, these example 6 tries to stay basic with just the matching functions. But again, in real world, you won't always have these two matching. It won't be like a sine and another sine inverse. They won't necessarily match, but I'm going to walk you through the steps. One way of looking at this, I'm going to use unit circle in a second, is to think of this with composition as a triangle. Here, this is giving me arc sine is my y over h. And you could think of this in terms of a triangle and say, triangle, right triangle, that we know the y is 1 and my hypotenuse is 2. But what we don't know, I forgot to write h there, sorry. Put that h in there. What we don't know is, what is my x? And you might not need to know. In this particular case, I wouldn't need to know, because it comes back and it says, all right, what happens when you do an arc sine is you solve for this angle. Arc sine gives you this angle there. And then, so that's what you would find. And then you take that angle and you would plug it into this sine. You'd say, okay, sine of whatever angle you solve for right here, which, let me color coordinate, that's a blue angle, so I'll make it blue right there. That sine, that angle comes down and you get your solution. Well, in this case, since I'm looking for sine, it'll just simply be 1/2 y over h. So this one is what I was saying is very simple, and I can prove it to you over here. I'll take this, type it in, and then I'm going to show you what you can do in case it wasn't quite as simple of a problem. So here we go. Sine, arc sine is the same thing as sine to the power -1, sine inverse. And I got to put that in Desmos as a fraction in parentheses. So 1/2, and I'm going to change this to a fraction. It says the answer is 1/2, just what I got. So we did do that correctly here. Now, let me show you with unit circle as a helpful guide, because not every problem is going to be this simple. Nope, that's not what I wanted. I want this one. Okay, copy. All right. If my y is 1 and my h is 2, the first that occurs is right here. What if this is the case? Then this tells me a couple things. One is that that is pi over 6, which means I could have done sine of pi over 6, which does equal 1/2. So sine of pi over 6, so now you know it's pi over 6. You go to find the sine, you realize you're right back to where you started, 1/2. Or the other thing we could have done is we could have also identified that this has to be the x value. X equals square root 3. If you do Pythagorean theorem, you would realize that this x would equal the square root of 3. If you're like, are you sure? Yes, because 1 squared is 1, 2 squared is 4, 4 minus 1 is 3, take the square root, you get 3. So that's a way of solving with the triangle. Okay, let me tie this together. I got a few of these to show you. Let's do this again. Cosine of 5 pi over 2. And I can get a unit circle on there. And I also can show you that this can all be done in the calculator. Typing it down, we'll just, I don't want to forget the calculator. I have a tendency to do that. So let me do the calculator answer first this time. 5 pi over 2, and it says the answer is going to be 0. So we know the answer is supposed to be 0. Let's see how to get that. Well, oh, wait. No, the answer is not going to be 0. Okay, so now we know what the answer is supposed to be. So how could we do this? Well, this time it's giving me an angle, which is not much of a triangle, but I can use the unit circle. So I'm going to go see what is cosine of 5 pi over 2. Now 5 pi over 2, if you look on the radians, it's not on there. But you could notice that's 1/2 of pi. This is 2/2 of pi. That's 3/2 of pi, 4/2 of pi, 5/2 of pi. this right here is equal to 5 pi over 2. If you don't like doing it that way, use your coterminal rules, and you would find out that this is going to be equal to cosine of 1 pi over 2. Now, what is cosine of 1 pi over 2? Right there. It's 0. Cosine pi over 2 is 0. So now that I know that this value is 0, I'm now going to say, what is cosine inverse of 0? So that means, and just so you follow, I plugged in the 0 right there. I need to find, this is inverse, so I'm going on the outside, the first place where x is 0, which is there. Say, what's the angle? Well, the quickest angle is pi over 2, and so the answer is pi over 2. So now we know the solution. We can test it in the calculator. Is pi divided by 2 the same decimal? Yes, it is. So we did do it correctly. Now this one I did not use a triangle because 5 pi over 2 told me nothing about the lengths. All right, and let me show you with tangent. So right now, here's where we're starting. We have tangent inverse of tangent a negative 5 pi over 2. And I can tell you, use the calculator, but this is the one I need to email Desmos about because they have a programming error here. They're going to say this answer is 1.57, which again is pi over 2. That's what the calculator is going to say. It's pi over 2, according to Desmos. Pi over 2. We know it's pi over 2 because we've gotten that answer just previously. But we're going to find out that is wrong. It's not actually pi over 2. Now, why is it not? Because the rule of math, remember, it's PEMDAS. For solving things, you start with your parentheses. So I would need to start with this and say, what is the tangent of negative 5 pi over 2? So using the unit circle, negative 5 pi over 2, I'm going down negative pi, so there's negative half pi, negative 2 halves of pi, negative 3 halves of pi, negative 4 halves of pi. This is negative 5 halves of pi. That right there is equal to negative 5 pi over 2. And so I'm wanting tangent, which means I need the y divided by the x. Negative 1 divided by 0. Question for you, class. Are you allowed to divide by 0?
No.
No. What do you call it when you divide by 0? Undefined is the answer. That right there is undefined. Now, if it's undefined, then the whole rest of the problem is also undefined. That is a math error there. And I could prove it to you if I just took it a piece at a time and got undefined and then said, okay, what's this? And even if I try to do that same undefined value, negative 1 divided by 0, what? I have no idea why it's saying that's an answer. It's undefined. I don't know why tangent's saying that. You can't, that's bogus. Let's go to the tangent inverse graph. Where was that picture? Way back. Tangent inverse. Oh, wait, that's not the graph here. Sorry. Y equals tangent inverse. No, I'm not looking at that. I'm looking at tangent. I'm sorry. So that one does exist forever, but that's not the part that's undefined. It's this previous part. Y equals tangent x. You will see that at negative 5 pi over 2, pi divided by 2, and negative 5 pi over 2, this graph does not exist. So you can't take something that's undefined and try to plug it into something else and it become defined. It doesn't work that way. So for that reason, this one is wrong. This should be undefined. Where am I? This one's undefined. Why is it undefined? Because this step right there is undefined. So don't get too carried away with Desmos until they get their programming worked out. That's wrong. The answer is undefined. Okay, and I was typing this in wrong. I should have been typing in tangent inverse of undefined. That's what I was doing wrong a second ago. Is that's the inside. That's what I should have been substituting in, and you can't do that. Okay, so yeah, your DOL number 6 here. A little unit circle help. All right, example 7. As I mentioned a second ago, you will not always have the same functions. So what do you do if you don't have a unit circle value? So 4/5 is not anything you find on the unit circle. My bad. Let me try this again. There you go. 4/5 is not anything you find on there. So if I can't find that, what do I do instead? Well, here's what I would suggest is you do how I started off the problem. You draw a triangle to solve. So I'm looking at a triangle here, and what I know is that the cosine inverse rather is 4/5. And then by way of reminder, cosine itself is x divided by h. So this right here is my x, and my h is 5. Now this time around, what we're trying to solve for is theta. This time around, what I'm going to notice is that I'm missing my y, but I want to find my answer is going to be whatever y divided by h is. So I need to find what my y is this time, because here's what's going to end up happening is I'm going to say, okay, what's the sine? And I need to plug in this theta. So I'm going to be saying, what's the sine of this theta right there, which will end up being y divided by h, which we know the h is 5, but we don't know the y. So that's what we got to solve for here. So to solve for it, I'm just going to use Pythagorean Theorem. Let's say that x squared plus y squared equals my hypotenuse squared. So x is 4, my y is unknown, my h is 5. 4 times 4 is 16. 5 times 5 is 25. I subtract my 16. It's adding to the y squared. I'm trying to isolate. So I'll subtract 16. Now I have y squared by itself is equal to 9. And I take the square root. Normally we would say plus or minus. But if you remember what I was saying earlier about the first and quickest answers, if they're tied on this, when you deal with triangles and trigonometry, we're going to take the positive value. So I'm just going to take positive 3. I just learned that y is positive 3. So my answer has to be 3/5. That's my solution here. Now what's really nice is we can just go type this in the calculator and we should get 3/5 if you press the fraction button. That's what we should get right here. Let's check it and see if we get that solution. So when I come to my calculator, it starts with sine up front, and then we had cos inverse, and my fraction is 4/5. And yep, lo and behold, we get 3/5 as a solution. So we did that one correct. So now let's have you try this one. Again, draw your triangle, solve for your missing side, and then you can come back and get the cosine of the sine inverse of 8/17. All right, let's take a look at example 8. It says write cotangent arc cosine x as an algebraic expression of x that does not involve trigonometric functions. So to kind of help you out here, I'm going to rewrite this as cotangent of cos inverse, and I'm going to put this as x, let me put it in parentheses, x divided by 1. There we go, and we want to write this as an algebraic expression. So here's what I'm going to do first. I'm going to start with my triangle. So my triangle here, if I have cosine, is that this value represents the x, so that's nice, that's my x, so x equals x, and this is my hypotenuse. My hypotenuse is 1. And so, but h equals 1. We don't know y, but I do know this is a right triangle, and this theta. Now this theta is what we're going to end up plugging into cotangent. So in a second, I'm going to have this cotangent come down, And this very same angle that technically I'd be solving for is what will supply our answer, which cotangent is sine is y, cos is x, tangent is y over x. It's going to be x divided by y. So I need to know what my y is. We know x is x, but what is y? And so I would do the same thing I just did. I would do Pythagorean Theorem, where we have x squared plus y squared equals h squared. In this problem, we know x is x. We don't know y. That's what we're looking for. We know h is 1. This is a little tricky because I'm trying to solve for y, so I need to subtract x squared. So I have y squared equals, I'm going to simplify that. That's 1 minus x squared. And so now the step to get y by itself is to take the square root. Now normally we do plus or minus, but with inverses we do quickest occurring. So I'm only going to be dealing with the positives. We're going to say y equals the square root of 1 minus x squared. That's my y. So now I can get my solution. My solution would be x is x, over the y, which is the square root of 1 minus x squared. Fortunately, we can't leave our answer in that form, so I'll write it all back out. And I'm going to shoot the square root up, 1 minus x squared, over the denominator, which is what was inside the square root. That right there would be my solution. So I know it's a little trickier because the steps were exactly the same as the previous one. What's a little different though is we never had a number for x, you just left it. And so that's what it means by an algebraic expression. That means leave it just with x's like that. Okay, now I have one for you to try. All right, so how has this been tested in the ACV? Well, honestly, a lot of it hasn't. It's just kind of built into normal problems. So I just kind of reviewed here. Let's see how we would solve some of these. Spiraling review. If secant theta is negative 25 over 7, well, the first thing we need to remember is that secant is h divided by x. And h is always positive, so I want to rewrite this as 25 divided by negative 7. And we're told tangent is less than 0. Y divided by x is less than 0. And now I'm going to plug in, if x is negative 7, that means y divided by negative 7 is less than 0. And check this, if I want to solve that, I can multiply by negative 7. We had this rule in the bell ringer. At least I remember I think it was on the bell ringer. If you multiply by a negative with inequalities, it flips the inequality symbol. So it becomes y is greater than 0. So we just found out y is positive. We know x, we know h. We're supposed to find cosecant here, which cosecant is h divided by y, which we know h is 25. And we know y is some positive number. But we don't know what. Well, looking at this, since they're both positive, f and g are out. And since I need 25 in the denominator, and it's got, the numerator, and it's going to be bigger, h is always either bigger than or equal to x and y. It can't be this one, so the answer has to be j. You don't even have to do Pythagorean theorem, but you could solve with your Pythagorean theorem if you wanted to actually get that 24. But that's a value. Okay, and finally, reference angle. Reference angle is the angle to the nearest x-axis. Angle all right, sorry about that. So it's the angle to nearest x-axis. Okay, so that's what a reference angle is. And we use the symbol with a theta and then an apostrophe after it, like a theta prime. So let me just show you where 840 would be. So first, the angle, as you go around, if you went one full circle, that would be 360 degrees. So we start at 0, and a full circle is 360. Now, very important is to include x-axis, both x-axis values. So we pass 180 in the process. So that gets me to there. And then I start making another loop. And the second loop is going to get me all the way to 720. That's by adding a whole another another 360. So if I add a 360 here, I think I get 540 if I'm doing the math right in my head. Okay, and then I start making another loop. Now on this one, I'm not actually going to get all the way around again, because if I added another 360, this would be 1080, and that's too much. I need 840. And if I added another 360 over here, let's see here, oops, let me get all that. If I added another 360 here, I think I'm going to get 900 on the dot, which means I went too far. I need to go 840, so I'm somewhere over here. Seems like to me about 60 away. Oh wait, that's going to be my answer. So what a reference angle is this? If you were going to create, so we said this angle went around once, went around twice, and started to go around a third time, and it ends there. A reference angle is like if you connected it to make a triangle with the x-axis, it's the angle that's sitting pretty right inside of this triangle right there. That right there is what we would call theta prime, which would be my reference angle. Since I went around 840 degrees, the closest x-axis that I'm connecting to is right here at 900. So the math would be 900 minus 840, which equals 60 degrees. That is our solution.